So we'll start off by having a look at some examples of gravimetric analysis questions. These are from the Nelson chemistry textbook as well, so not our usual Heinemann Chemistry 1 books. But this one here is a worked example here. So here has like some scenario. There's usually some like background in these questions. You just kind of skip over that, but maybe it's good to get a sense of what they're looking for. So they want us to find out how pure some barium chloride is. So like when you think purity, you think of percentage, yeah? So they say here that a sample of their commercial barium chloride was weighed and found to have a mass of 10 grams. So they've got 10 grams of barium chloride for which they want to work out how pure it is. They dissolve this in water and then they add sulfuric acid, okay? And then this forms a precipitate of barium sulfates. Remember, gravimetric analysis is all about forming precipitates, isolating them, and then weighing them out so you can work out of how much of something that you have. They filter, dry, and weigh this, and they have this mass here, 10.55 grams. Okay. So they want to find how pure this is, yeah? Percentage purity. That'd be nice. And the way that they find this, I suppose, is they have barium chloride. They know that there's barium chloride well, that's what they're analyzing for. But they turn this into barium sulfate because this can be precipitated and then isolated. Okay, so this here is soluble, but this here is insoluble. So this allows for grav analysis. So with these kinds of problems, the first thing you always have to do is work out an equation if you're not given one. Okay, so step one is to determine this chemical equation. And the reason why you need to determine a chemical equation is so that you can work out the mole ratios of the different substances with each other. So it allows you to work out, in what ratio, in this case, like you want to find out the ratio of the two highlighted things here, barium chloride and barium sulfate, because you are forming barium sulfate, you can measure that, yeah? We've got a measurement for barium sulfate here, right? And then from that we can work out the number of moles of barium sulfate, okay? So I'll just write this out. So with the mass of barium sulfate, we can work out number of moles of barium sulfate, which is our number of moles of like this known substance. And then we use it to work out the number of moles of barium chloride. And then we can work out the mass of barium chloride. And once we have that mass, we can then work out the percentage purity by like whatever the mass this is over the total mass will give us the percentage purity. And that's exactly how the sample solution goes. So they've written the equation first. They then turn the mass of barium chloride into number of moles of barium chloride, okay? So to do that, they use N equals M on capital M, R. So you can see here, so they don't use capital MR, but they use capital M here. That's the molar mass here, capital MR. They've got mass here given to them, highlighted in green. And then the formula N equals M on capital MR they use there. So they work out the number of moles of barium chloride first, and then with barium, they work out number of moles of barium sulfate first, and then with that they do the stoichiometric ratio. And you can easily, sorry, I've been writing this wrong. So they work out mass from the mass of barium sulfate, the number of moles of barium sulfate, and then from the number of moles of barium sulfate, they work out the number of moles of barium chloride. Apologies. So this is stoichiometric ratio of 1 to 1. Okay, based on the chemical equation, you can see here that there's 1 to 1 of barium sulfate to barium chloride. And so once we've got number of moles of barium chloride, we can work out mass of barium chloride. So number of moles of barium chloride to mass of barium chloride. And the final step is to work out purity. To work out purity, you just put the mass of the barium chloride that you determined over the total mass of your sample. So the total sample was 10 grams. The mass of barium chloride that we actually got was 9.4 grams, 9.415. So then if you plug that in to this purity equation here, so this here is mass of barium chloride. This here is the total mass. That gives us the purity. So we get a 94% pure sample there. Technical grade, not very good for synthesis, but that's what they do to work out their purities there. Okay, so we've got a couple of other samples. These ones don't have work solutions, so we'll work through them. So let's read through this question and see what they want. We'll write down everything that we have. I think it's a good practice to just like note down all the information that we can use to work out this thing here. So groundwater from an old lead battery, so lead is probably what we're dealing with. Lead battery manufacturing site was analyzed gravimetrically for its lead content. A 2,000 ml sample was treated with sodium sulfate solution. So you would see here volume of sample. So this is your total volume. I'll put it into liters. 2 liters was treated with sodium sulfate solution until no further precipitate was observed to form. So if we're looking for lead, they've added sodium sulfate. So lead is a cation. It will form an ionic compound with the anion that we've added. We've added here the sulfate anion. So I guess we are forming this precipitate lead sulfate. So PbSO4. So lead forms a 2+ ion. If you can't remember what the charges on the ions will be, a good thing to do is have a look at that electrochemical series that we had a look at, that we've become familiar with last chapter. That tells us the kinds of ions that various metals might form. So transition metals, it's hard to predict like what kind of cations they form just by looking at the periodic table. Unlike the group 1 and 2, with all group 1 metals, they form an ion of +1. With all group 2, it's all +2. But with transition metals, you get a range. Okay, so to know what the ion charges will be, you just look at that electrochemical series. So if you look at electrochemical series, you see that lead's reduction reaction is shown. Okay, and so lead forms these 2+ ions by losing its 2 electrons. And that will help you work out this formula. So you have to be able to do all this just by reading the question, okay? Like that lead sulfate is your precipitate, but you have to accurately write out its formula. If you write Pb2SO43 or something, assuming that lead was 3+, you'd be wrong. Or if you thought that lead was 1+, you'd also be in trouble. But the good news is, if you identify the precipitate incorrectly and you write the chemical equation based on an incorrect formula, you get consequential marks. So assuming that you use that chemical equation's stoichiometric ratio correctly and carry it all the way through, like all your calculations are correct, just your chemical equation was wrong, you get all the marks except for that wrong chemical equation. So you just lose a mark. So we've got this precipitate here. They say here we've filtered and dried to a constant weight, and they got a mass of lead sulfate to be 1.214 grams. And we need to find the level of lead ions in the groundwater. So they want us to find a concentration in milligrams per liter. So concentration of, C of PbSO4 equals milligrams per liter. Okay. Right. What do we do? So we've got mass of lead sulfate here. We want to find, wait, they don't want lead sulfate, they want lead ions. So concentration of lead ions in milligrams per liter. So we want to find the mass of lead ions first so that we can work out concentration. Let's make a plan. I always need to make a plan with these. We're starting with mass of lead sulfate, and the whole root will take us to concentration of lead ions in milligrams per liter. It's good to have the units. So let's do this. Let's write this. Okay, and then you can kind of backtrack to work out how you can get there, or you can try to build your way towards the goal, towards the final target thing here. Either way works. So from mass of lead sulfate, I know I can easily work out number of moles of lead sulfate, and then I can use that to work out number of moles of lead ions, and then mass of lead ions, and then with the mass of lead ions, I can work out the concentration. And so I'll write in between all the steps, or all the things that I would use. I would use N equals M on capital MR here. I would use stoichiometry here. And I would use M equals N times MR here. So just rearrange formula of this one here. And then the last one, C equals, so concentration is always like some amount, in this case, mass over volume, okay? Mass divided by volume. We want to find milligrams per liter, so we just put in this concentration equation here, milligrams divided by volume in liter. That's the plan. So let's do it. Number of moles of lead sulfate is going to be mass of lead sulfate over molar mass of lead sulfate. I don't know what lead is. It's huge. So let's have a look. 207.2 plus 32.1 plus 16 times 4. Whoops, I don't want my compass, I want this. So it's going to be 207.2 plus 32.1 plus 64, 303.3 grams per mole. So that's the molar mass of lead sulfate. And then we just plug that into this equation here. We've got the mass up here, 1.214 grams divided by 303.3 grams per mole equals 214 divided by answer, 0.004 moles. So here we use stoichiometry. Now we don't have a chemical equation. We can write one if it helps, okay? So you can do something like, this was essentially what we saw with like the precipitation of lead. And this might help some of you work out the stoichiometric ratio. You can say it's 1-to-1 just by looking at the coefficients, fair enough. Another way is you just go look at lead sulfate. You look at the formula of lead sulfate, yeah? And you look at lead sulfate and you see, okay, I've got if in 1 unit of lead sulfate, if I had 1 lead sulfate unit, so one which consists of 1 lead atom, 1 sulfur atom, and 4 oxygen atoms, how many lead atoms would I have? And you could just go, okay, what's 1-to-1 ratio of lead to lead sulfate? If you had 100 lead sulfate units, you'd have 100 lead ions, yeah? You can just do that by looking at the formula, or you can write out an equation. Either way is fine. But the thing you have to show is that the number of moles of lead ions is the same as the number of moles of lead sulfate. Because for every lead sulfate unit you have 1 lead ion, okay? It's crucial that is made very clear. So you've got a number of moles of lead ions there. So then the mass of lead then is going to be 0.004. Whoops. Multiplied by the molar mass of lead. 0.829 grams. Now we want it in milligrams because the concentration is asking for milligrams per liter. So to turn this into milligrams, you know that there's 1,000 milligrams in a gram. So you would multiply this by 1,000, okay? And if you go milligrams per gram, that's nice to do that. That gives you 829 milligrams of lead. Now the final thing you need to do is work out the concentration of lead ions. Concentration of lead ions is mass of lead over the total volume, okay? So we have here 829 milligrams. The volume was 2 liters, so it's going to be 415 milligrams per liter. And that is our answer. So you can see all the steps in there somewhere, all over the place. But it's good to make a plan to work out like what you're going to do. And it gets easier to make this plan once you're very familiar with every individual step. So when you're looking at this plan, like you would have had to know very well how to go from mass to number of moles, okay? If I wanted to get from mass to number of moles, I would have to apply this formula circled, okay? And then if I wanted to work out the number of moles of a substance, once I know the number of moles of another substance, I'd have to use stoichiometry, like here. And then to go from number of moles to mass, use that kind of formula here. And then concentration, the last one. Concentration is always some amount over some volume, okay? As you can see with the units. If you can't remember concentration formulas or anything, that's fine. Just think of, how can I get this unit, okay? How do I work out, how do I set up an equation to get this unit here? So you work with the units. You want milligrams divided by liters, essentially. You want to have a milligram value that you're dividing by a liter value. So you just factor in, you just schedule in or work out your equations around that. Okay.